to this computer. That seems right. All right. So we're going to go over some of the important changes to exam two. So I know exam one was pretty recent. We used to have only two exams, I think, in this class. Now we're doing, I think this is the first time that we're doing like three, and it has a bit less topics than maybe the old exams had. I don't know. I don't know what you guys feel about that, but there's going to be less topics to like study every time, so you're able to focus more in depth on, one thing at a time rather than just have a lot of different topics and the same amount of questions. So personally, I think it's good. I don't know what you guys think. Um, we changed it a little bit this time. So um, we used to have 12 multiple choice questions before, and we thought, well, that's 60% of the exam, but we really want to be testing you on your programming skills. And, of course, multiple choice, you either get it right or wrong, and you lose 5% on every single question, which is quite a lot. So we asked, can we just change it to 50%, which is still high, but it's a little bit less. And in exchange, we've added another programming problem. So I don't know. I think all the exam grades are out already for exam one. So you probably see that we're able to give partial credit for those programming questions. So it's probably going to be better for you guys, I think. And of course, if you don't answer questions on the programming problems, we can't give you anything. So if you try and just write anything that you can, that's also, something that you should do because we're allowed to give as much, we're allowed to give that partial credit. So we're going to go on with this format. We're going to do 10 multiple choice questions and the fill-in questions, just like before, two debug problems, the same way that we had before. I know that there was some issues with the wording on exam one, where it was asking like logic versus logic and syntax errors. We intended it to be both logic and syntax errors every time. I wrote the question when I was really tired, so I think I missed that, but we've changed that, so it'll always be looking for syntax and logic errors, and essentially, we give you the expected behavior of the function that you're going to be debugging, and that's how you're going to determine those logic errors. But you also need to be looking for those small things like those Python syntax problems. And then we're going to do the two small programming problems. And those are the same thing that we did before. We're just going to have one extra one. They're typically only, you could technically code them all in a few lines, and that's kind of the aim. So they're not like huge solution things, but it will take you a little bit of time to actually develop that solution or think it through. And then finally, one large programming problem where you might have a larger function. You might have to think it through a little bit more, but I think that it's still doable in a short like amount of lines of code. So I will always say don't overthink things. Yeah. There's only a few topics. So we're going to be doing number systems, and that's just going to be covering can you convert between binary, octal, hexadecimal, and decimal. And typically, can you convert between those three and decimal? There's a lot more different number systems that you could be using in computer science, but we're going to focus on these three. So as long as you can convert between these three to decimal and decimal back to those three number systems, I think that it'll help you out a lot on the exam because there will definitely, well, probably be some questions on that. So I would keep that in mind. So take the time to practice, and we'll go over it a little bit. Then there's the data types, which of course we've been covering in the lab recently, all those things with like lists, those tuples, sets, dictionaries, all different ways of storing information. But just can you understand why they're implemented that way? Maybe just understand a couple of their key functions. And we've compiled a lot of the slides here from the labs because we've covered it before. But I would just say look over it briefly, try to understand why did they make this data type and what's the purpose for it, and that'll probably help you the most. And then finally, we're going to have recursion, which is an interesting topic. It's typically, I feel, the most scary topic for students in this course because it's just hard to understand, and we don't cover it in too much depth, and especially because I don't know if the professor has actually covered it in lecture yet. Uh, he's covered it today. So yeah, so there's going to be recursion on the exam, and actually a pretty sizable portion of it will be on recursion, or at least trying to use recursion in your program or understanding it. So we we're not gonna ask you like super in-depth like explanations like tracking what values are in recursive calls, but we will try and ask you to like use recursion in some small way, probably not in a super complex way, but that is something to keep in mind. There's I think that there will be a few questions on that. And of course, it's going to be hard since, he's only just covered it today. I think the next lab that you're going to do next week is also going to be on recursion. So you'll get some practice doing that. It won't be a super complicated one. So keep that in mind. Try and read up on it more. And we've got some resources about it. So. There's a lot of instructions on those exams. I got a lot of questions afterwards about some wording. We've tried to like update that so that it's more clear during the exam so that you understand exactly what we want from you. Typically, the multiple choice questions are just what are the output of this code, and that's relatively easy to understand. Again, as I clarified, we're going to always be looking for logic and syntax errors on the debugging, and then the programming problems. Yeah, we're trying to be more explicit in what we want from you. So you might see an instruction saying, okay, we'll use this specific method to calculate something. And I know that we had that on the last exam where it was like use a for loop to calculate the numbers in the specific sequence. But even then, we had seen some issues with some students using other methods. So we're trying to be more explicit with that. So hopefully that'll be helpful for you guys. But the exam is not too challenging. I think this exam is a little bit easier. So don't rush it. Don't try and rush through it. You've got less multiple choice, probably less tedious questions. I know that there was a couple of those on exam one. So try and take your time because it's really easy to lose points on those small questions. And again, 5% per multiple choice, it is a lot. So you do want to make sure you get as many of those points as possible. All right. And the best way to go about doing those problems is to actually write them down, use pen and paper, and actually try and track. If something's asking you to keep track of a variable, write it down and try and keep track. Like if there's a loop, try and see what are the variables at each state. It really helps, and you have the time to do it. And it's probably better to do it the first time, really in depth, and then not have to go back to it because you can see all your work there and you have confidence in yourself. And yeah, so for the error finding questions, debugging questions. Again, there's a lot of small things. I know that there was the exact same error for both of the debugging questions on the first exam, which I thought was pretty funny. Just a single colon missing on the function definitions, right? And actually quite a few people missed those. And so we want to make sure look at every single line. We try and make it only 6 lines so that you can actually look in depth. And they won't be really complex errors. It'll be something small. So if there is a syntax error, that'll probably be what it is. Look for the colons. There might be some, I don't know, but it might be something like that. Yeah, and again, try and write it. Even if you don't know for sure about something, you should still answer it because you get partial credit. We're much more lenient on those things because there isn't one specific way of doing these questions, right? And I've seen when I was grading exams before, I would see a lot of students not submit anything at all on some questions, which I understand. If you don't understand how to do it, you might feel like, oh, I just don't want to try it at all, but still try, all right? Because we can give you some points for that, hopefully, even if you write some small things like just write the function name, all right? So try and do that if you are stuck, and that would be my tip. And when you do those questions, before you start coding, think about what it's asking you. All right. This is probably the most important thing that you'll learn from this class is really how to think, how to like solve problems more so than the programming. Okay. We want to teach you how to get into that like sense of logical thinking. So when you do these problems, you're going to want to look in and say like, what is it asking me to do? What do I need to take in? What do I need to do? Just on a high level, like what is this function even doing? Do I need to loop over stuff? Try and answer those questions before you even start programming or even writing the program, because then it saves you a lot of time. And a lot of the time, even I do it, most of us do it, we try and write immediately, see that we missed something, and then we have to write something, and we don't know how our changes might have impacted our original code that we wrote, right? So try and make that plan before you start. And I like to draw stuff out. I like to draw like little diagrams saying, oh, do this first, then do this. And it seems like such a small thing, but if you have that there, to reference to while you're programming, it might become easier for you as you go on. And I know that it might seem like a waste of time, but once you do it and you get good at it, it'll really help boost your efficiency when writing programs. And especially since this is a time setting, we want to make sure that you're able to do the thinking and also in a reasonable amount of time. But most important thing, all right, this is the most important thing, is that you should sleep before the exam. We open the practice exam until 10 a.m. the day of the exam. And I get notifications every single time someone submits the practice exam. We all do. And I was awake until 5 in the morning. And I was seeing like submission after submission, like 100 or 200 submissions at like 5 a.m. So I don't know if any of you guys are here, but try and do it before. We've made the deadline for the practice exam that I just made this morning. We've made it due the night before, so that's a little bit better. But please don't wait till like the last second to do it, because it's like if you're tired, you're not going to do as well as you'd hope, no matter how smart you are, in my opinion. All right.
I can attest to this. I took a test like 2 hours ago on networks. I think I've gotten 12 hours of sleep in the past 3 days, and I don't think I did very well. So don't do that. Also, are the previous topics from exam one going to come back on the MCs? Yeah, there are probably going to be like loops and
Yeah, I mean, some of the topics that we learn are going to build off of each other. So, while it's not explicitly saying we're not going to just explicitly test your knowledge on conditionals or loops, we kind of expect you to know how to use them, and then in conjunction with the new topics that you've covered that we're covering, right? So keep that in mind. You will be expected to use those for loops, use those conditionals, and we're not going to explicitly test that. It's going to be explicitly testing something like a list, how a list works, but we might still expect you to use those conditionals. So uh, in that sense, yes, they will come back on the multiple choice. So yeah, are there any questions about the exam format or the practice exam that we just put out? Has anybody actually done the practice exam yet? I saw there was like 3 submissions or something. So some people are really ahead. And I hope that it'll be helpful. And I don't know, do you guys think that the last practice exam was helpful for you guys? See it? Yeah, okay.
I thought it was slightly easier
Slightly easier?
than the real exam, the multiple choice.
Okay, oh, so just the multiple choice?
The program, I mean, there was like Fibonacci, and then it was
Right.
like, the real exam was like, basically like Fibonacci, like, fun.
Yeah, well, I can tell you, yeah, okay, so I made most of the questions on the exam, so you can blame me for that. But I made the practice exam after I made the real exam. That specific question at the end I made after, like that was one that I just changed. I just read some random sequence in a random textbook, and I'm like, this looks interesting. Let me put this in. And yes, it was more complicated, but the reason why I had made those questions like that, I guess I could have made something more challenging on the practice exam. But I just said, well, the solutions are very similar, actually. They were almost identical, my solutions that I wrote for those 2 different programs. I was like, okay, maybe that'd be helpful. And I don't know. I mean, of course, I can't say, I can't show you the real exam, so we can't compare this practice exam, but hopefully it'll be fine. I mean, I did write it at like 6 a.m. this morning in like an hour, so I can't promise that it'll be necessarily harder or easier, because of course my idea of harder and easier is a little bit skewed, I would say, but I am trying to make it at least representative, because I am making the practice exam based off of the exam that Karen and I made. So that's all I can say about that. It is fully based off of it. It's not the same thing, but it is based off of it. Any other questions about that? All right, well, hopefully it helps. I mean, it was basically, we didn't have practice exam before. I was just like, well, I think it would be helpful. It seems like the average was way higher than we expected. So congratulations. I don't know. I mean, they gave me a number that we were supposed to expect for an average, and it was like 70%. I'm like, well, we got like an 80+% on the average for this class. For a class of 700 plus people, that's really good. So you guys are doing really well. I don't know if it was because of my practice exam or some other resources, but I also think it's good to have something that's exactly representative of what you'll do versus just looking on those documents and trying to solve questions with no pressure in a sense. So hopefully that helps. Yeah, I think you guys really are just that good. You started the practice exam at 10. Oh, at 9:59 on the day of the exam, so I wouldn't know. Okay. Okay, that's just we're not gonna allow that anymore. We're not gonna allow that anymore. It's gonna close midnight the day before the exam. Honestly, I probably should make it earlier, but I'll give you time. So, but don't do it at midnight, all right? So let's see. Should we go straight into like the slides? What do you think next? Okay, we're gonna try and do Mentimeter. I've never tried this before, but I think this will be really helpful. So if you guys pull up a device, I think you can do it on phone and laptop. Let's see. Let's get this started. Slide 33. Yeah, we'll send out these slides. They'll have a lot of information compiled from the labs themselves. You can see that my graphic design was really good. I thought it was kind of funny, but uh, I don't know. Set. Okay, whatever. Let's go. I'll just open it here.
Yeah, just open
It might already be open. Oh yeah, yeah.
it. Go to the other one. Go to the other.
I closed it.
Did you-
All right, I actually opened it this time. Guys, I'm really not good at using computers. It's very ironic. I struggle. You can join the Mentimeter using the code 92845195. I've literally never used Mentimeter before, so I'm also learning. Oh God. Oh what? All right, who's sad? Who's sad? Come on, guys. Come on, guys. You're gonna be happy after we do this. By the way, I think I forgot to like say my name, but I'm Newman. I mean I don't host any discussions, so I really don't meet many of you guys because I'm spending time making the exams. So if the exam is really bad, you can email me and tell me how bad it was, and then I'll try and fix it for the final. And then we've got Karen here.
Hello. Newman also runs the auto grader, so he's very much like the backbone of the course. So yeah, he does, as you can see, he doesn't get a lot of sleep.
I'm Ryan. I just run a few discussions. So, and I have office hours. My office hours are pretty cool. Tuesday, 6 to 8. You should come.
My office hours are Friday. We don't have class tomorrow though, but I also make your discussion slides. That's why they have all the GIFs on them. And that's why we started doing the frog game.
She won't let me make the slides because she says I don't have the ability to use good GIFs. So there's nothing I can do about it. Okay, how are you guys feeling about the exam? We've got 20 responses so far. Are you guys on Zoom able to see the Mentimeter? Just to make sure. Yes, you are. All right, let's read this. I'm not good with Gen Z lingo. I see deep fried, cooked, half cooked. All right. Cook it. There's a lot of cooking going on here. Is that how they say it? Oh yeah, you're going to cook, right? And during this exam? All right, I'm just gonna stop talking. Not smart, anxious guys. I think it'll be okay. If we prepare here, we'll do a good job. We'll do a good job. All right. I see that people are thumbs up. All right. Well, listen, I think that because the exam average for the last one was pretty good and he asked me to make a very hard exam, I think that you're going to be okay because this exam is probably going to be easier. All right. That's my opinion. But of course, it's like, I don't know. We'll see. But he did tell me to make an exam with an expected average of some certain number of like 70%. And you guys exceeded expectations with like 15% higher. And he's like, what happened? No, I'm joking. I'm just trying to raise everyone's grade, guys. So hopefully it'll be okay. But we'll try and help you guys. All right, what is a variable? All right, I think if we're at that stage, then we need to, never mind. All right, let's go. So, I don't know how this works, so you're gonna have to teach me, Karen.
Just hit enter.
Okay, so all right, we're gonna go through these together. All right, so first thing, just go straight into it. All right, we're gonna do some number system conversion. All right, so converting decimal to binary. This is something that's very important. Why is it important? Because I think it'll help you on the exam. Just so you know. All right, so what do we need to do, guys? Let's think about this. Let's think about this. Let's take some time to do this. 2 minutes isn't that long. You'll have much more time on the exam. So if you can do it in this amount of time, then you really will be in good shape. I actually love decimal to binary conversion, guys. It's very fun. If you're computer engineering and you are going to take digital logic, I'm also a TA in digital logic, and this is what we learn. All right, we teach you how to do this type of conversion. It's really cool. And if you want to talk about that class, you can ask me later. But this is useful. We got 26 seconds left. I think since I'm using a block, if people want to actually explain their answers, I can literally throw this at you and you can talk. I think it'll be I think it'll be interesting. So we might try this out. But actually, I don't want to break anyone's computer, so we'll see.
I also have ducks.
We're gonna snipe you with ducks. That's what I hear. Okay, so I see 14. It doesn't seem that seems a little bit off, but I think generally we're doing well here. Okay. So, does anybody actually want to come up here and do it? You want to come up? Here. What's your name? Oh, actually, you can come up here, then you can tell everyone your name. Here, it's okay, it's okay. You,
Good job.
you can write it out here, or at least try. At least try. Okay, I'll clear the tables once you get up here. All right, you can use the pen and figure it out. You can explain it here once you're. Yeah, I'm also learning. I forget these all.
So what I did is that first I went to the biggest number up to 46, which was 32. And then I wanted to make it the second biggest number I could, which would be 40. So I used 8 to get 40. And then from there, I used 4 and 2 to get the remaining 6. And then that's my binary.
Is there like an easier way to do it?
Okay.
Not just-
Yeah.
All right. All right. Any questions about that at all?
Yeah, that's like very confused. Like,
Okay.
is there an easier way to do
I
it?
don't know if you guys can actually see this. Let me make sure. I'm sharing the entire screen, right?
Hello.
I just need to make sure. All right. So everyone's clear about that so far? No?
Hello.
Okay, wait. What was the,
Hello.
hold on.
Type in the chat.
Mhm.
I think,
Yeah, what? I mean,
okay. The way that I do it at least, so we start with 46, right? So I try and think about, so that's the number we're converting. So the number is 46. 30, the way that I think about it is I'd look for the biggest power of 2 that goes into whatever number I'm converting. So in this case, the greatest power of 2 would be like 32 because 64 is greater than 46. Yeah, so 2 to the 5th. And then once you kind of know that, you can sort of map out like the rest of the powers of the 2. So 2 to the 1. Oh my God. 2 to the 0. And then you can sort of be like, okay, there's going to be a 32 here. 46 minus 32 is going to be 14. 2 to the fourth is 16. 16 is greater than that 14. So we're not going to have that. So we can put a 0 there. And then we can go to 2 to the third. 2 to the third is 8. 8 is less than 14. So we can subtract our 8 from that 14 and get 6. So we're going to put a 1 there. And then 2 to the second is 4. So then 4 goes into 6. So subtract 4 until we get 2. So then we can put another 1 there. And then 2 to the first power is just 2. And then 2 fits into 2. So we get a 1 there. And then we've reached 0. So then we can just fill in that 0 for the last one. Does that make sense? Okay. Yeah. I mean, if you get the right answer, you get the right answer.
Yeah, so for on Zoom, I see that you're asking, does it go from 2 to the power 0 to 2 to the power 7? It doesn't necessarily. In this case, we go up to 2 to the power of 5 because that's the highest power of 2 that actually fits into 46. That's actually less than 46. Because if we go to 2 to the power of 6, that'd be 64. 64 is bigger than 46. Oh, you're asking in general? Well, I mean, if you had a number that was gigantic, you might need more. So you really just use as many powers of 2 that you need until you fit your number. So that's how it works. Does that make sense? Okay. All right. Are we all good on that? So, okay. Let's go to the
Hello,
next one.
can y'all hear me?
All right. Oh, there's no types. Okay. Oh, what just happened? There's a leaderboard now. Vote goat. Clippy. Okay, never mind. Are these like automatically generated names? Oh, okay. Okay. I was gonna say, doctors, Doctor Centipede. All right, you guys, we can go. All right, let's go. All right, 21 players. Oh, okay. Okay, so we've got an octal value 100. So 100 in octal to decimal. And what is octal? Yeah, so it's the 8 based number system. So binary is 2 base, right? So you only have digits 0 and 1. Octal has different numbers. I also think this will be very useful for the exam. I will literally say this about every question, but I do think it's useful. I think octal is the one that people find the most confusing just because it's probably the least used out of the 3 that we're going to cover, but you still will need to know it. We just made this whole session of a giant frog game.
Do I just do that?
I'll just play all frog games. Got 5 seconds left, guys. And then someone has to come up here. Correct answer 64. I see a lot more answers. So I see some interesting ones, but 64 is the correct answer. Does anyone want to come up and explain? All right, you want to come up here? All right, good. All right. Yeah, you can do it on the here.
I'm only doing this for a duck. All right. So, all right. So for octal, we work in terms of 8. So you have 8 to the 0, you have 8 to the first, and then we have 8 to the second, right? So this is 1, 0, 0. So if you kind of like correlate those, and this goes here, that's a 0, so that's nothing. This goes here, it's a 0, so it's nothing. And then here, there's a 1. So that's 8 squared, which is just equal to 64.
Why would you like?
I'll pay 20.
So makes sense to everybody, mostly, hopefully. It's the same thing as binary conversion. And again, it is actually the same method, right? You just use a different base, so base 8. And there's actually a lot of different bases that you can cover outside of this class, like base 64, which is actually quite commonly used. But that it basically just changes, which value is used here in those calculations, right? So, all right.
Why is 8 to the first power 0? Let me look at the way I forgot. Oh, so if you line up like the 1 and the 0 and the 0 with like the powers of 8. Yeah, so you can just sort of like you just kind of match up where there's a number with because basically, yeah, you line up the powers of 8 and then you do like 8 to the 0 times whatever number is in the 0th position, 8 to the 1 times whatever number is in the like first position, and then 8 to the second times whatever number is in that position.
Make sense?
Yeah.
Oh, yes. Okay. All right, good. We
But
good.
you should do a we'll do a hexadecimal question to practice that. Because I realized I don't have one in the Menti, which is my bad.
Here's your bad.
Okay. Let's see. Oh, this is cool. 0x. Let's do this to decimal. I'll give you guys like 2 minutes to do that.
This one's probably the most common type of conversion that you'll see, especially as you go further on into the computer science classes. We typically use hexadecimal, so if you can do this, this will, really help you later on. And it's in the exam. Guaranteed. I leaked it.
Okay.
Visual logic research.
We're not all here.
You could be.
No,
Take it.
no,
No, wait, grab it.
I'm leaving.
We got just a minute left. Hopefully it's not too bad. I don't know how much time you guys have per question on the exam, but you'll probably still have more time than this. So if you can do it in this amount of time, then you will be really well off. And it won't get much more complex than this. And then suddenly I'll put like a 10 digit hexadecimal number, but you won't see that. I promise. All right. So is it 154? Do you guys think it's 154? Yes? Anyone want to come up and show us why? You want to come up here? All right. Let's see. You can just write. Oh, okay. So we can write for you if you want.
So it's basically the same thing before.
Here, I'll hold it.
Oh boy.
I can write it if you want. Just here. You can verbally explain.
So it's the same thing as before. You basically take 16 to no pole times the first element counting from right to left. Yeah. But in this instance, because we're looking at hexadecimal, you have to also convert the letter back to the number. A is 10 in this case. So that's 10 times 16 to no pole plus 9 times 16 to the first. 16 times 9 is 144. And then you just add 10. That, yeah.
All right. All right. Yeah, which duck do you want? You need one. All right. Does that make sense to everybody? You know, the way that we teach it in digital logic is a little bit different. But I think it's actually helpful to see this because, sometimes we just don't like to do the math. And actually, I guess you still have to do the math, but like I like this other method that we use where we, kind of split the hexadecimal number into 4 bits at a time. It's actually, I mean, you convert to binary first and then convert to decimal, which again is adding an extra step. But I always found this like very intuitive for me because 16 itself has to be represented as 4 bits in binary, right? It has to be, well, I guess the values 0 to 15, which is 16 different values, is represented with 4 bits. So you can split up each one of these hex values into 4 bits in binary, which is kind of interesting. All right, so then you can do that conversion. So let's say this 9 here, what would that be in binary? I think you actually do this in the project too, as well, right? In the RLE project. I don't know. I don't know if you guys have gotten there yet, but I know that you do the conversion from hex to binary. So I guess this actually is a hex to binary question. So what is 9 in binary? Yeah. What is going on with this thing? All right, what'd you say? 1, 0, 0, 1. Right, so that's 8 plus 0 plus 0 plus 1, right? And that's 9. And what would A be in binary? So that's 8 plus 2, right? Makes sense? And so that's actually the binary conversion. I guess if you then wanted to convert it back to a decimal there, you'd have to do the same calculation. It's just I feel like it's easy to understand. And that's why when you do like in the project, you can convert to 1 and then do the conversion all from binary. Does that make sense, to everyone? All right, let's move on. Okay, there's some changes here. I don't know who anybody is. I'm sorry. I love metal. All right, let's go. Oh, I see some code. Oh no. Okay, this looks like an exam question. I'm scared. We can do this. All right, are you guys all able to see it? It's fine. Okay. All right, so what do we have? We have a list. We have a result variable. We have a for loop. So yes, you are tested on for loops technically. For num and nums, if the number is divisible by 3, then do something else. Otherwise, no. I like to vocalize my thoughts. All right. I'll do every 5 minutes. All the labs. You can do it. All right, well. All right, looks a lot better this time. All right, we got almost everybody. All right, does anyone want to walk us through it just really quickly? You get a free duck, guys. I would have loved to get a duck. when I was in this class. You want to come up here? All right, let's go.
Fun fact, the reason I do the ducks is because when I was taking advanced prog, my professor promised ducks and he never gave them to us. So now I do it so that you guys don't have to experience that disappointment.
Oh, hi. So we go through each element in num. So we start with 6. So 6 is divisible by 3. I probably won't write anything. 6 is divisible by 3. So we go to the next if statement. 6 is greater than 5. So we add 5 to result. So now result starts at 1. And then now it's 6. Then we go to the next one. It's 2. 2 is not divisible by 3. So you add 2 to the result. So you get 8. Then 11. 11 is also not divisible by 3. So then you add that to the result as well. So you get 19. Same with 5. Not divisible by 3. So you added 24. And then 9 is divisible by 3 and greater than 5. So you add 5, which you get 29. I have a blue one. Sorry, they're at the bottom. I honestly don't know. I got you. I got you, girl.
Dump them all on the ground.
You know what? That also works.
They're so small. All right. Is everyone clear on how that works? I think a lot of people, if you don't really review how a for loop works, because we usually would talk about it in terms of just iterating over a range of numbers like 0 to something. If you don't review that this for loop here is iterating for every number inside of the list, then just keep that in mind. That's just a small mistake that some people just forget. So hopefully that'll be fine for you guys. So any questions? Should be okay. All right. Let's continue. All right. Whoa, there's some new stuff here. Yes. So we have a big list and some interesting line under that. Okay. I also think this is useful to know for some reason. Keep this in mind during the exam. 6, 12, 14, 9, 22. Oh, it like doesn't let you do it with spaces or no.
There we go.
Oh, there. Here. All right. Okay. So, does anybody want to explain to us how this specifically works? What- which- I need to get someone new first, okay? Because we want to spread as many ducks as possible. All right, you want to come up here? We need everyone in here to get a duck, guys.
I don't know if this like takes if I need to write it down.
Explain it.
But okay.
If you want the whiteboard.
Okay, so basically we have our list X and the little asterisk, the little star next to A means that okay, so if there was no asterisk, it would be like too many arguments, like not allowed. So the little star saves us, and basically it takes on all the extra elements in the list that B and C can't take because they don't have the star. So basically, because A has a star, it'll take as many that can't be taken by the other variables that are taking elements from the list.
Perfect. Very nice. Yes. Of course. Okay. Are there any other questions about that? Or does that make sense? Are we confused? That's okay. Okay, I'll just write out a random 22, 22, 24. Okay, this is just a random list of numbers. When we assign multiple variables to a list, what was the question? Okay. Okay, so when we assign multiple variables to a list and we have the star, if it doesn't have the star, it can only be assigned to one of the elements. So like C, so it goes in the order of the variables. So like C is only one element because it doesn't have the star. So C gets matched to the last element in the list. Same with B, it doesn't have the star. So it only gets matched to one element. So it goes to like the second to last element. And then the star A just takes all of the rest of the elements. So if we were to do like A star B C equals X, then like A would get matched up to 6. So it's just one element. C would get matched up to 24, and it's just one element. And then B would be like all of the rest of the ones in the middle. So it just goes by order. And if it has the star, then it just takes the rest of the elements. Yes. Star A, star. I don't think you can do that.
I mean, we can test it out, but I feel like it'll blow up. We'll see. We'll see. I love blowing up Python though. That's actually the best way to learn in my opinion. Probably. We'll see. It is really hard to know every single feature of Python. So, you can go in and test it. And that's what I like to do. I forget a lot of this stuff. So, you just go in, see, can you do this? It's probably written down somewhere, but I think it's more fun to just see if it blows up. Multiple starred expressions in assignment. So they know that you can't do that.
Yeah. Did in fact blow up.
So unfortunately, we can't do that, but this is how we learn, guys. All right. Any other questions about this? I saw you were asking. Oh, okay. 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 All right. Anything else? Any other questions about this? Is it all clear? If you take anything from this, just take the whole thing because it might be there. So keep that in mind, guys. All right. We can. It died? You're lying to me. All right. I see some lists here, so this is gonna be interesting. Answer fast to get more points. Don't rush it. All right. It's okay. What will be the output of the following code? We have a list here with a bunch of courses. Programming 1, 2, advanced programming, data structures, operating systems. We're trying to print out something from that list. But what is that something? This might be useful for your exam. In seconds, 9, 8, 7. I'm joking. All right, and 504C. All right. So technically, right? Technically right. Technically right. I don't even know what the difference between these two. Oh, you have different quotation marks for some reason. I don't know what happened there. I see 503C. I'll technically give this right. All right. So I could explain it, but that wouldn't be any fun. So I want to ask someone else that wants a duck. You want to come up here and explain it to us? I feel like I recognize this type of question from somewhere. So it would be good to know. And do you want the white one? If this helps.
Okay. Okay, so basically you have your list and then you have like your indexes. So like this would be 0. What did I write here? Okay, so like this would be 0, 1, 2, so that you know that index 2 is equal to COP 3504C. So now you're within that index. And then within that index, you want to look at your fourth index here. So you have 0, 1, 2, 3, 4, 5, 6, 7. And then here it starts at 4 and it goes all the way to the end. So you just get 504C.
So remember, guys, starts at 0 for the index. I know that this is like probably the one of the confusing things that we do, but yeah, starts at 0. Yeah. Yes, we want all negatives. So that's really hard to understand. Oh my gosh. All right. So let's think this through. So what does the first what does the first part of this do here? Okay. So which one would that be? Okay, so we'll be within this element of the list. So this is the second last element. So we basically just count -1 would be the last element, -2, second last, right? And I'll list out the indices just so that, it's easy to see. So what next? So third to last being, okay, so this element, right? And then the third to last, or which one? Okay, this element.
Okay, wait, so what's our start value? What's our start value? So what is our like start value in our range? Yeah. So the first number, this is like our start, this is our end, and like this is sort of like our jump. Okay. So if we're starting at index -1, index -1 is going to be the last element. So that's going to be the 0. And then our end element is -3. But remember that our end element is exclusive, so we don't count that. And then our jump is -1. So that means we're going from -1 to -3 by -1. So we would just go like backwards by -1 each time. So it would be 0 and then 3. And then -3 is exclusive for our range. So it would just be 0, 3. Does that make sense? Okay, cool. Are there any other questions about that? Yes.
Oh, these brackets here with the like the list indexes here? Is that what you're talking about? So it doesn't print with. Well, that's the thing. So in this case, our courses, the elements inside the courses list, they're strings, okay? And so what happens is when you print it out, you're printing out a string, and these brackets here indicate that it's a list, all right? So what this thing here says is that you have a list with one element that is 504C, right? And in this case, the actual data type within our list is a string. So when you print it out, it'll print out a string type. And I don't think that that comes out even with quotes either, right? So it would just be 504C like that. And if you tried, yeah, but if you try and print out like, yeah, it's just weird because it's just one, I mean, here, this is just indicating that this was a list. If you had something like this, let's say, um, it's just weird. I don't know. This is kind of a weird example, but if you had every single element within its own list inside of the list here, instead of it being a string, and then you try to do it, it might print something similar. I don't know, right? Yeah. But in this case, since it's just printing a string, I think technically this is the actual answer that will come out if you try to print this out, right? And if you were to try and print out a tuple or something, it would actually give you those brackets. But it's not. So that's just dependent on the data type, right? Are there any other questions about that?
The quotes are fine though. If like for whatever reason on Canvas you submit it with quotes and it like marks it wrong, then your TA will go back in and give you those points.
Yeah, because I think it's easy enough to understand. I mean, we use quotes to indicate string, but I think technically in the editor you just don't see those, right? All right, well, that's fine. All right, let's keep going. All right, let's get out of here. This is going to be interesting. Okay. So given the following code, what's the output? So we have two lists, and we have a third variable, but it's not a list. And we're doing something on it. Bring it out. So if you remember the set function from the lab slides, you remember what it does?
That's pretty good. Okay. Does anybody wanna come up and explain that one? Let's go. Woo! You do need it, yeah. All right. You want a whiteboard? You want to just
I feel like I can use the mouse.
Okay.
Okay, so we see A, B, and C is set A. And then it says C add 6. And since C is A, we add 6 to the end of it. So yeah, that's it, friend.
Yeah.
So yeah.
color?
Yay. Blue.
Blue is very popular.
It's the cutest one because it's like pastel.
You're so real for that. Okay. Are there any questions about this? Yes. Ah, okay.
Like add your alter into both the value of the set. It's the set. Yeah.
Yeah, so sets are unordered. So what that means is that like you can't do like a set Like if you have a set that's like 1, 2, 3, you can't do like X of 0. You know what I mean? So yeah, so you can't like so append isn't a thing for sets. Sets use add. Um for lists, that's where you can use append for because those are ordered. So then it adds it to like the end of the list. Dictionaries? I mean, you can't index like a dictionary. Like you can't do like dictionary of 0. Like you can't do that because you have to dictionaries you reference by key, right? So I don't yeah, you can do dot up. I don't think you can do dot append for dictionary.
No,
I
I
could
mean
be wrong.
the thing is they design like people who create these data structures in Python designed it with a different name to indicate that, for that specific data type because they have different behavior, right? So dictionary wouldn't have an append method because it doesn't really make sense for the implementation. That's why I mean the general way to just add something to a dictionary is just to use that dictionary, the key value and then or the key and then set the value and it just automatically adds it for you. Well, tuple is an immutable, right? So you wouldn't be able to add anything. And that's why it also wouldn't have that function.
For lists, you could do list.insert, right?
I'm pretty sure that there's a function that will let you insert into a specific index.
List.insert. So it'll be like whatever you want to add to your list. And then you can specify the index. If you wanted to add to the beginning, you do it. I'm pretty sure that's it.
Yeah. Does that make sense? And again, it's like there are a lot of different functions. Someone else designed these for us, but I mean, it is good that when you are actually using these data structures, it's good to search up online and just see like what type of functions have people made that help us out. Because technically you could write all of this yourself, but it's really nice with Python because they give us a lot of those methods for us, right? And if we just learn how to use them, that's really all we need. But of course, since every different data type has its own special behavior, they might have different methods just depending on their use case. All right. So hopefully that's clear.
Oh, actually, I wanted to touch on something. Oi, okay. Um, if we have a list that's like 1, 2, 3, 4, and we do like list dot, wait, do you guys know what the difference between append and extend is? Okay. Uh, yeah, you can go. Go ahead. Go for it. Yeah, okay. So if we were to do like list dot append of like this, what would happen if we were to do this? Yes, so this would become an error, right? Because our list only takes in one element, or append only takes in one element. If we were to change this to be like list dot append of this, what would happen here? Oh, yeah, so yes, okay, yeah. So if we were to do that, then you would get like a nested sort of list inside of our outer list. So just also be careful of that. Oh my God. Hold on. Eh, I'm struggling. Thank you.
What the?
Okay.
There you go.
Okay. Um, if we were to do, okay, if just nix that. Um, if we were to do list dot extend of that, would this work? What do we think?
Trying to figure this out, guys. We don't know either. So this is how we're going to test this. Let's try this. Let's try this out. So what do we have? We have a list here. We have a list x equals 1, 2, 3, 4, 5, and we want to extend. Oh wait, yeah, extend. I don't know. Just do this and see what happens, I guess. Okay, so the extend function takes exactly one argument, so this doesn't work. Same way that the append doesn't work, right? So then how are we going to fix it?
Yeah. Okay. Yes. Yeah. So basically, when you extend, even though it takes in multiple elements, you still have to put those multiple elements inside of a list when you use extend. Sorry? Oh, okay.
Yeah,
Okay,
so,
okay, okay. Oh, okay.
so you notice it doesn't just add an extra element to the end of the list that has like all 5 of these values, but instead it actually just creates a new list technically with those extra values. Um, and it's all within one list now. So does that make sense? So that would be the difference. So append, you would just be adding something, typically, I think it's just to the end. Um, and the extend is just taking in another list. It's kind of like merging 2 lists together.
Yeah, so if you were to do append with a list, then you get like a nested list inside of your outer list. Good one. Yeah. Mhm. Yes. So if you print out, yeah, X index 5, you get that entire list because it's that entire item. And then if you want something inside of there, then you got to index again.
Sense?
Yeah.
All right. Understand.
Has anybody answered a question and not gotten a duck, by the way? Okay.
Or female. All right, 7 of 9. All right, guys, this looks like the lab. I love this question. Well, it's not as bad as the lab, so that's somewhat okay. We have a dictionary. Yeah, the lab had 4 nested dictionaries. This one only has a dictionary within a dictionary, so it's not too bad. It could definitely be worse. That's all I can say. Ten seconds. Remember how a dictionary works? Key value pairs. Can I do thumbs up? I can. All right, correct answer is error. There's no B in item 2. Okay. All right. C, no. I'm sorry, guys. All right, looks good. So anyone want to explain? I don't think it's too bad. You don't necessarily need to write if you don't want. You can just talk us through this one. This looks very similar to some question I've seen before. So
So in the dictionary, it looks for item 2 first, and then but B is not a name of any of the keys, so it can't look for a value. It can only look for a key, so it can't find what B is, so it prints an error.
I do like this answer though. There is a lot of enthusiasm and sadness at the same time. It's more emotion than I will ever show in my entire life. I'm sorry, guys. That's how I was born. Nothing I can do.
Fun stuff.
Fun times. My favorite thing. All right, let's go. Did I skip it? My bad. All right. There we go. I'm not a Mentimeter expert. I'm sorry. What is the output of this code? We have a function, fun times, takes in something, does something, returns something. Hmm. I'm going to talk about today in lecture. I understand that one lecture probably isn't enough to understand fully, but if you can come to understand this, then I think you're on the right track. And for questions like these, definitely write things down, keep track of where you are. Just like the questions on the first exam, it can be hard, it can be easy to get lost. So don't try and do it in your head. All right? It happens more than you think. Seven. Correct answer is 16. All right. I did not attend today's lecture. I'm very disappointed in you. Whoever it was. I'm joking. It's okay. I understand. I understand. But this is going to be super important. All right? Because recursion. Recursion is a hard topic, and I understand that. But the next lab will go over it, and we're going to go over it now. So let's see. Close, close, almost. No. Actually, we got some that are pretty close. Does anyone want to come up here and walk us through? Similar to what we did with those while loops, those disgusting for loop questions on the exam. We have to keep track of stuff. You want to write it out for us? Or at least, yeah, let's try. All right. Yes, I could plug this into the programmer, but I'm not going to do that. This is more fun. All right, you can write here if you want.
Um, so basically it starts out, you're putting in 5 and 2 into the function, whatever it's called, fun times. And the first thing it checks is if this is 0, which it's not, so it returns 5 plus this function of 4 and 1. So then you have to go back to it again, but plug in 4 and 1. So it goes to 4 plus the function, and you keep doing that until you get a to be 0 here. Because once a is 0, then you can like get the 1 here. Yes. So you're subtracting 1 every time from A and from B. So B goes negative eventually, but you keep going until this reaches 0, not till B reaches 0. And you do it one more time here for 1 plus this 0 and -3. And since here it shows that it's if a equals 0, return 1. So that means this is 1. So 1 plus 1 is 2. So this here returns 2 now. And 2 plus 2 is 4. Which means this returns 4. And now 3 plus 4 is 7. And since this returns 7, 4 plus 7 is 11. And this returns 11, so 5 plus 11 is 16.
Very nice.
All right, nice job.
I'm gonna put this back.
Yeah, so as you can see there, it looks like a lot, right? It's pretty similar to some of those tedious questions that we did with the while loops. Obviously, this I don't think that this is necessarily as bad, but it's hard sometimes to understand like, oh, you have to go all the way down first and then work your way back up. But of course, that is what it's doing, right? So I think that it would be good to practice similar questions. And of course, you can change it up by passing in a different argument, right? And then seeing can you calculate what the result would be. Okay. So just by changing the two initial arguments, you might get a different answer. So if you didn't attend today's lecture, I would definitely say try and look over this because um, I've definitely seen a question like this. So this would be good. And it's not too hard. All right. It's only a few steps. So try and work through it yourself. Maybe even just take the same function and change the inputs as I was saying and see what you can get. All right. All right. Who wrote this function? Okay. All right. So what will be the output of the following code? We have a function named dub_w. Very similar. Oh, yeah, it's all Karen. That's why it looks so weird. No, you can't do it in your head. You'll lose track. I used to think I could do it all in my head and then I would make. I understand. It's fair enough. Reminds me of my friend that would do integrals in his head. Try to keep track. I did not understand. It is very easy to lose track of where you are, though. I can say that, and that's most commonly what issue you'll run into. So just be organized and try and come up with a systematic method to solve these questions. All right. I'm trying to do it in my head, but I'm struggling. Probably everybody. I wish I could give myself a thumbs up. I can't. It's so sad. All right. Correct answer is 7. Does anybody want to go through it for us? Same way that we just did it? Or with your own method? You want to try? All right, let's go. Let's go. Let's pull this up. I'll give you some space. Here you go.
Okay, so in the result, W is 3. So if W is greater than 5, you turn 1. So, but it's not 5 now. So you go down to the else statement, and then it's 3 plus W, dub, and then 3 plus 5. 3 plus 2 is 5. And then this, like a professor did, this becomes, look at the if statement, W is not greater than 5 yet. So I go down. It's 3 plus W. And then since W is 5, it's 5 plus 2, which is 7. And then you look at this one, the W is greater than 5, so it returns 1. And you look at the whole thing, you look at the 3 plus 1, it's 7.
All right, so make sure that you can do this. All right. Because it's not too hard, but again, try and keep track of it very neatly, and then it becomes much easier than you think. I know that many people are scared of recursion, but it's actually a very useful tool. All right. I don't know if that's everything. Let's see. Okay. We've reached the end of the Mentimeter. You want to do it? No. Okay. We're gonna go through one example of what was it, list recursion?
List comprehension.
Oh, list comprehension. Okay, you want to do it?
I can do it. Okay. I forgot to put this on the Mentimeter, so that's my bad. But we'll just go over it. 2, 5, okay. X 2, 4, X, X modulo. Okay. I think I did that correctly. Kind of just made that up on the spot, so hopefully
Test this
that
out.
was correct.
Read it to yourself. Python is very similar to English, so just try and read it and see what is it actually doing, what type of conditions is it looking for, and then try and approach it by looking at it first before you start looking at the actual numbers. Think about what it's actually checking for. All right. Give you guys a minute. And if anybody actually just wants to come up here, you can feel free and explain this. I don't think it's too bad. Anybody? Well, then I would have to do it myself. Well, since we came up with this question on the spot. So let me do it really quickly. Okay. Does that look about what you guys got? Now, do you want to come up and explain it? I understand that though. I would always be too scared. I'm like, yeah, I understand. It's okay.
Okay, I mean, it's not that crazy. Okay, so x plus 2 for x and a if x mod 3 equals 0. Okay, so let's iterate. Okay, so 2, that's mod 3 is not 0. So next one, mod 3 not 0. Next one, 9, mod 3 is 0. So, okay, here's B. This is us building B. So x plus 2 is 11. So we keep iterating. 13, not mod 3, 0. Okay, 1, same thing. And then 12, yay, mod 3 equals 0. So then we add 2 to that and we get 14. And that's, but it wouldn't print like this. It would just be like that.
Yeah, so we'll print it out with the back.
Yeah.
Thank you.
Very nice.
It's not too bad. So Basically checking for all the ones that are divisible by 3 was I.
Yeah. It's essentially the same as if you were to do like,
Yeah, it's basically the same as doing a for loop, going through every element of the list and then doing a if statement, but you can do it all in one line, which is really cool. Right. Yeah.
right?
Yeah. All right. That makes sense to everyone? I don't know if you guys did any of this in lab 6 or not. I think some people did. I saw a one-line solution for the entire Connect 4 using list comprehension. Uh, I assume that most people didn't do that, but you can. It is very powerful. I'm not suggesting to do that, but anyways. All right. What do we do? Yeah. All right. So now that we've gone through like basically every single question that you might see on the exam in terms of multiple choice, we're going to try and go through some of those longer questions so that you kind of know exactly what we're looking for when it comes to debugging. So I don't know if I can even write on this, but I can.
Oh, you can.
Maybe. We'll see. Oh, you can. All right, let's try this out. Oh gosh. Wait. Oh, is that Zoom annotations?
Oh, I think
Maybe that works. All right. So we're given a function that does something. The thing about our questions that we'll have in the exam is that you'll actually be given, what it actually does, right? So you'll see exactly what the function does first, and then you have an idea, what is it supposed to do, and then that's how you'll figure out your errors. So in this case, because we don't know what it does, the first thing that you might jump to when you look for errors is probably syntax, right? I don't know what you guys think, but since I don't know what the function does, we can either first try and look for all the syntax errors, or we can try and understand what the function does. Um, but I'll look for everything for all of the syntax errors first, because that's probably the easiest thing to find out. It's always the easiest one to miss too. If you try and do the logic errors first, and then you miss something like this, right? Like this. So there's one error. I found one. Okay. So missing colon, and this is how you would write it. So we've got our lines 1 through 6. So we would say line 1, missing colon. That's it. All right. You just say add a colon. We don't expect you to give like a really long response. Just say, all right, there's something missing here. That makes sense? So if you guys want to go through it yourself just really quickly, see if you can find any errors, and then I'll call out, just ask what you guys find. Well, let's think about it.
What do you think?
We're trying to find the errors.
Because I thought you said that you would use add for the set and for the list. And it said, my set equals a set. It declares a variable for set. And then another mistake would be a parameter. It says numbers list and it says for in numbers. So you can either change the parameter, you can change the argument. You can either put numbers in the parameter or put numbers list in the argument. And I think that's it.
Yeah, so you'll probably see like in the function or in the question that will say, okay, this function takes in this argument here. And as you see, it's not the same, right? So we'll probably change the name to whatever the parameter is there. So that's good. So then you'd say line 3, change variable name, right? So line 3, you change the variable name. Give me the pen. Okay, and you were saying there's what else was there?
Use a pencil.
Okay, so why can't we use a pen?
So
Okay, so the set doesn't have that method, right? So line 5, change to add, right? If we want that expected behavior. What else? There's no colon here, right? Okay, that's a good one. I didn't see that.
The first thing you should do is just check for colons.
All right. Anything else? Whoever wants to go. Where? Line 4, why? What is it trying to do? Right.
We do want, when you're setting something equal to something, then you need to do checking.
Yeah, so here we're using an assignment operator. We're trying to assign something, but we're actually trying to use like a conditional operator, right? We're trying to check if something's equivalent. So we'd say line 4, change, right? Anything else? Yeah, sure. I mean, I don't see anything else, so it seems fine. But
If you're calling the set function, you use the parentheses. If you were to do the curly brackets, then you wouldn't have like the set there. Why would it be add and not append in line 5? So sets are unordered, right? An append adds an element to the end of a list. So we use add for sets.
yeah, and this set function here, it is essentially doing the same thing as creating an empty set, which in Python is just that, all right? Now, the set function has no arguments, so it basically just makes that. And that thing that's stored into my set is literally just these curly braces. And yes, you can initialize it by saying my set equals those curly braces. Does that make sense? Oh, right, yeah. So you have to actually put something inside here. So you could put an element inside if you wanted to start this out. But here, I guess this is for empty. So this would be for making essentially this. But all right. Anything else? Any questions on this? And this is essentially all you need. Really, all you need to do is just say, okay, this line, this is the error, and what you would change. Okay. It's not too complicated. You don't need to write too much. Let's see. All right. Oh gosh.
Yeah.
Okay. Another error finding question. This one's a bit longer. There's actually a function in this one. So what's the first thing that we do when we check for errors? It's always the simplest ones that are the easiest to, overlook. And for some reason, missing certain small syntax features counts the same amount of points as the other stuff. Are we missing something at the end of 85? Well, because I guess there's no extra element there, so yeah.
Oh my gosh. If it was, if there was like no comma there, then that would be good. But because it's the last one, you don't need a comma.
Any other errors? Okay, so there's no colon here. That's good. Anything else? Okay, I'll just go, yeah.
Sorry, say that again. You said this would be keys. So what would keys get us back? Yeah. Um, but if we look at if we look at the rest of our like for loop, we have these two variables like exam and grade, and then we're printing out like the name of the exam and then like the grade. So you're close that like this is wrong, but like, what should it be replaced with instead?
You want both.
There's one that gets both the keys and the values. Yes. Yeah, there you go.
So dot items will return a tuple
Mhm.
of the key and the value. All right. So you notice in the for loop it says exam comma grade. That's actually a tuple because the parentheses are optional. It's really cool.
Yeah, so when we have more than one variable here, that means that we're sort of splitting up the tuple. So exam will correspond to these values, and then grade will correspond to these values. So that's how we sort of get both sides of our dictionary.
So we're defining the set as a list. What does a set even do here? It doesn't
You
do
know what? It doesn't do
it
anything.
doesn't do anything, but I think it would still cause an issue, wouldn't it? Because of the name, you think? Well, I guess in this case, because set already is the name of a function, right? Sorry, can you explain that again? Well, yeah, it's already like a predefined like function name. So basically we couldn't name it that, right? I believe, right? Right. Sorry, what was that? Okay, yeah, that's good. So print total. Yeah, because I think in this case, if you tried to print grade here, I think it would throw an error because grade is only defined within this for loop, right? And as soon as you exit the for loop, grade isn't defined anywhere else on this level. So it actually it won't even work there. So it's a good catch. I guess you can name it that, but it's weird. What's the point of this?
You know what I like?
Is there anything else? Yeah, I mean, there's no point of this function anyways, but whatever. That's just we don't need that. I think that's everything, right? Are we missing any more colons? It's always possible. You never know. All right, but I think it looks good, right? You guys agree with that? So I didn't list it out every single one, but you would just say, we would have the line numbers, and you just say, okay, line this error, that error. That's it. All right. All right. So the the part where you can get the most points. All right. This is probably the most useful because now all of this debugging plus the FRQ is worth 50% of your exam. So the way that we're grading your FRQs is by looking for certain features of your program. All right. For example, if you have the correct like function definition name, all right, just that we already give you a point. All right. So we want to see certain steps like followed. So if we ask you to write a function, start out by writing out the function definition. So write out the name that we give you and then all the parameters exactly as we say, and that automatically gives you some points. That's kind of what you want to think about. Like as we, tell you to do something, can you write it out in Python? And so if you don't write anything at all, then you won't get points, but you can get points just by doing that, even if you don't know how to write the function. All right. So that's why we say try and write anything that you can. So before you start writing the internals of your function, think first, what are we asking for? What are we taking in? And then do you need to actually return anything from the function or do you need to be printing? And I know for the first exam, I think I made one of them a return and one of them a print, right? And I don't know if I specified it or not, which I think was yeah, it was my mistake. But I think it should specify on this exam if we do have to do that, that you return or print. Because sometimes you return and sometimes you print stuff. And that's just depending on how you write the code. And then first start out by saying, how do you want to solve the problem? So a lot of these things have the same, you can solve the problem with the same, or the same problem with a lot of different methods, but sometimes, we'll ask you, can you do it in this method? So for example, we could have asked you that question on the last exam with the Fibonacci style sequence. We could have asked you to do it in recursion, for example. We would say, okay, you must do this in with recursion. And so it'll probably highlight that there. So make sure that you keep note of that, because for this exam, we'll be pretty explicit about it. And if you don't do it in the method that we specified, then we probably can't give you points for it, unfortunately. All right. So keep that in mind, and I'll put it in red and bold. So hopefully that should be enough. And before you start writing your function, think about the steps that you need to do to achieve the task that we ask you to do. All right. Again, always think through your program before you start writing. It's always the fastest way to solve, because then you don't have to go back and try and understand what you did or modify your already written code with something if it didn't work. And then just test your solution. These solutions should be relatively short, so you can, do it on paper and just say, oh, what if I pass this input in? And we'll usually give examples, and if they match, if they match logically, then that means that you are probably on the right track. And again, you guys obviously have experience doing that with all the multiple choice questions. You can then feed in inputs to your own function, see, does it actually work the way that you intended it to? And if it does, then you're more than likely to get like 15 out of 15 on your big answer question, right? So that's what you want. So that's why you should still test, even if we don't have an editor to test. Just work through a couple examples logically the same way that you do with those multiple choice questions. And if you do that, then again, you are more likely to get 100% on those FRQs. Are there any questions about that?
It can be kind of overwhelming, I know, when you see like a really long question and you're like, I don't even know where to start. So just try and like start with what you know is going to be there. So function definition, parameters, which we give you. If there's a recursion problem, it'll probably tell you that you need to use recursion for it. So,
Don't use a loop. Wait, yeah, don't use a loop if it says to use recursion, all right? And we'll be pretty explicit about it. And again, we won't give points this time. There were some people that used recursion on the last exam, even though I wrote like use a for loop, and they put the recursion inside the loop, which is like, in reality, it doesn't actually do anything, right? So, but I guess technically it still satisfied the conditions of my problem. And I was like arguing with everyone, like, this shouldn't count, but I guess it technically still counted, and I was mad about it. So we gave points anyways. But I'm going to be more explicit about it, because I don't want that to happen again. It was a big thing. All right. But anyways, it'll probably specify. Yeah, it was a heated conversation. I have a very strong stance on this. Anyways, if you see some question like this, usually the questions will be a bit longer and give more detail. But this one that I put, I believe this is on the practice exam.
yeah. These are just the practice exam free response questions.
So these are the questions that I wrote at like 6 in the morning. So do I remember how to do it? We'll find out. The thing that you want to first do when you start out seeing a question like this, again, I'm not even going to write out any of the code in with the text. I'll just write it out by hand, like my steps to solve this thing. The first thing you should always do, just look first and see, given a list of integers, okay, I already see I'm taking in a list of integers. So there's going to be an argument to my function that's going to be a list, right? That's one thing. So I'll say args, there's going to be a list. And then it says write a function, longest sequence, taking in the sequence variable, which should be this list here. So that would be, why is this like so bad? So that's gonna, oh gosh, this is like really bad. So I can already get some points here. I don't know how many points this usually gives, but it's at least some, usually 1 point, right?
I think it's 1 point. Yeah.
Still better than 0 points. That's a good step. Because I mean, again, we've actually seen it a lot where people don't use the same name or something similar, and it's like a very easy point to get. So make sure that you do that. It says that we're going to find the longest sequence of the same value. So the way that you can, understand it is just by looking at these examples. Usually we'll give 2 or 3 examples of what it's doing. And this code, I think, is relatively simple. It's saying, okay, look at the sequence of numbers here and find where there's the longest grouping of them. So here we see there's a group of 2. There's 2 of them. Here there's a group of 3 4s. So there's 2 here, 3, 2. I don't know why this is like doing this. This is very annoying. There's 2 2s, 3 4s, 2 2s, 1 1, 1 3, and 2 5s. So evidently there are going to be the output is going to be 3 because we have a group of 3 4s, right? And then we look at the other example, we can see, well, group of 2 1s, 2 3s, 1 4, and then 6 3s. So then we're going to output 6. So what is the first step about solving our problems? What method are we going to use to even just get started? Am I going to do a recursive solution for this? I probably wouldn't, all right, because it looks relatively simple. It looks like, oh, you're just iterating over the numbers, so that would most likely be it'd be easier to do it with the loop, in my opinion. So you would say, I want to use a loop, right? And what do I need to do? Well, I need to like check. I guess this isn't like, yeah, I need to check between these consecutive numbers and see how many there are. So I would need to somehow store the numbers until something changes, right? So maybe I could say, maybe I could have a variable that says the current value now. So in this case, it would be 2, and then keep checking, is the next value still the same? And then maybe tally it up, all right? I don't even necessarily have to store any of those numbers. I just have to count them, right? So then I think maybe the easiest thing that people would think is like, oh, let me just store these things. But I think you can actually just set 2 variables. Like 1, what value am I looking at now? And then 2, use a conditional and check. Okay, if it's still the same number once you go to the next one, then just tally it up. And if not, then just reset it to I guess you could have another variable that stores like the max that you're at right now, the max that you found, and then keep going, then reset back to 0. I don't know. I mean, that's just one way of doing it, but that's how I would start out.
Does anyone want to give us a line of code?
You can program this right now.
Yeah.
Do it. Oops. Oh my gosh. There's text everywhere. How do I get rid of it?
Yeah.
Oh gosh. All right, let's start. I know that you won't get an editor, but at least you can see this is what I would do in the Canvas text box, right? So I would take the name that they ask for, and that would be this. And then I just thought of the different variables I might need. So I wanted to use a for loop, right? Let's think. Does anybody want to like come up and try it for themselves? There, just back there. But you can come up here and write it if you want. All right, let's try it. We can work through it. Because we're not going to be able to run the code, right? We're not going to be able to run it, but at least we'll see if we can like logically work through it, because that's the most important part.
Where?
So let's think about this. What would you do? Try and
Wait,
explain
also,
it.
yeah, talk through what you're doing.
No. Strange? Yeah, I guess. What's up?
Okay, so what does this line do?
Okay, for this line, what you need to do is like from total number right here, and subtract 1 with the total number of the line of position, what I say, and then for I or on iterate from 0 to amount number from the sequence.
And why are you minusing one to it?
because this cast will start with 1 and the original list will start with 0. So -1 is balancing out.
Okay, so like what would length of sequence -1 if you were to index our like list in example
Yeah.
1, like what would that go to?
The 1
Like length of sequence -1, what would that go to?
that would go to, for example, right here, this list 2 2 4 4 4 2 2 1 3 5 6. This amount start with 1 and 0 1 2 3 4 5 6 7 8 9 10 10 total. But if you use a link, there would be like 11.
Okay, yeah. So our length is 11.
Yeah.
And you're saying that you want the range
That's 10.
to go to 10?
Yeah.
What about the,
0, 1, 2.
does the range function include the last value or does it exclude it?
Isn't excluded.
If
Yeah.
it is excluded and you put in
So it's still
11,
being, yeah.
would you need to subtract it?
I don't think so. Yeah. At this point, we'll lose. But
It's just like a small thing.
mm,
I guess you could do it that way if you were,
can.
you could.
Range function
Yeah.
starts out as
yeah.
so, and then
It depends on how you implement it.
yeah, and in this
Yeah.
case, the range function
Start with 0 1 2. So it will stop at 10.
if you start out. Yeah. And you could, and in this
Wait a
case,
second.
it will start at 0. because
It's
you've
just
only-
easier.
This is what we did, like, in the browser, when he was showing an example for part two or part three
Yeah.
of the project. And for count rows. If in an example, he goes for iron range, like the black data lines.
Yeah. So why does, right.
I-
Yeah. Do you know why he does that? Like why he ends it at -1? Okay, that's okay. So he ends it at length -1 is what you're saying, right? Yeah. Because I believe what he does in that example is like if you have a list that's like 1, 2, 3, 4, 5, the length of this is 5, right? So because I think what he does in the count runs function is he looks at like the I and then he compares it to like the I plus 1. Exactly. Yeah. So that's why you have to do length -1 if you want to end here, because if you end here and you do I plus 1, then you go sort of out of range. So the way that you did it, if you want to do it with like the I plus
Yeah.
1, like that
That's
works
why I'm
perfectly
trying to
fine.
do it.
Gotcha. Okay. Yeah. And then you could also hypothetically start from the index of 1 and do like I and I minus 1, in which case you could stop at the end of the list. Yeah. So you just have to be careful about like the sort of range and the length of the index that you're in. Anyways. Would you like to keep going or would you like to take a break?
So for now. Mm. Yeah. Okay.
You just try this out on your own as well. I mean, I think that it would be good. Then you can test it out too. If you go to the site that we're on, online GDB, you can run code without having to go on PyCharm, which is pretty nice. So, I mean, try this out. It's not too long of a solution, I think. A few lines. Just try and think of how you do it. And again, you can implement it in many different ways, as we're showing. And everyone will, do it a different way. Usually we kind of expect like certain methods to be more common, but
Where's the count the most number, and then print that number out. So what I'm saying right here is this number equals the first number equal to the second number, and then we print one, and then those how much what I say is for those number who equal to each other have the most number, and then print that number out. So like if the count was greater than no.
Does anyone else have an idea? How can we perchance test if our count variable is the biggest or the max value? Yeah.
Like,
Oh.
kind of like star, like, dot, and then you want to do something.
Yeah, for a list, right?
Yeah,
Yeah.
because this is like X, right? I think you could use that, but I'm not sure. Yeah, I remember you boiled it on the video.
Yes. So if you were to do max of like, where are the slides? Where did the slides go? So if you were to do max of like this list right here, you would return like the highest value in that, right? We're looking for the longest length. So you could use max.
Yeah, I mean, look, the thing is,
Get this straight.
technically you can use that, but like that's not really what we're looking for, right?
You could do it that way.
I mean,
You just have to approach the problem a little bit different.
because in reality we're counting like the length of different like I guess it is kind of like the runs in RLE. Does anyone have any? Yeah. Yeah, and you can do that because I mean, again, we're not actually asking you to identify which number it is that was in the longest run, I guess. You have any thoughts? Mm-hmm.
Have another conditional, quick count.
You want to try it out? Because that's what I was thinking. No, that's good because again, there's multiple ways of doing it, right? And that's why when we are looking at it, we've got a few different solutions that we look at. But this is kind of what I was thinking about.
Yeah, you can.
Well, honestly, my original idea with approaching this was slightly more convoluted. I was thinking that you could like go through the sequence and then you could progressively you could turn all the numbers into like lists. And then at the end, you can compare the length of each list. And whichever has the greatest will be what it outputs. That makes sense. Like,
The list of each number.
yeah. But I'll be honest, I'm not the best when it comes to like, because you would have to make a dictionary and then you'd have to add each number to a, a list. But
We can make that a little simpler.
Yeah, you were talking about the max count variable.
yeah, so we can make a new variable. Yeah. Now we can initialize it as 0. Let's see. I guess we can add. It's not a statement.
if the amount of counts that you're at right now is bigger than you're just going to reset max count every time.
Yeah. So that would happen after. Um, oh, wait. We don't want the count to reset before the max count gets checked.
So then maybe do the check inside of that statement.
Yeah.
Maybe. Basically, you're checking if they're the same, then add to the count. Otherwise, that means that you stop having like consecutive numbers, right? Then you check if your count right now is greater than the maximum that you've got.
What you said is
Good.
trying to get into the max count. And then counts. I guess.
You want count at 0?
Oh yeah,
Or
one.
yeah, there you go.
So maybe that works. And then
I think this works. Counts me. Oh, do you want a duck? Oh, you want?
green. Thank you.
Okay. If we iterate through the list and use the dot count function, then compare that with the max count, would that be allowed? This is a good strategy. The only issue is that if you have a sequence like this where you have 2, 2, 4, 4, 4, 2, 2, 1, 3, 5, 5, if you or like if you were to count the number of twos in this, then you get like 4, right? Because it just counts how many of that item are in the list versus like the number in a sequence, which are like one after another. But this is a good idea. I appreciate the idea, but you just have to be careful because there could be like it could be like 3, 3, 3, 1, 3, 3, 3, in which case you'd want the longest sequence to be 3 and not like 6.
This is only checking consecutive numbers.
What?
From what I understand, it's like only checking consecutive numbers and then adding every time and then resetting once it's not consecutive anymore. Oh, okay. All right, okay, that makes sense. Yeah, and basically you would just write this out. Even if your syntax is not perfect, try and write out those steps. And I mean, look, you can add like notes on what you did, but in reality, as long as you think it through, what we would be looking for while we're grading is really seeing this loop first to see, okay, you are going through the list, and then we're looking into we're seeing that conditional saying, okay, you're checking, are they the same? Are the two consecutive elements the same? And then we would expect something that does this, that actually just either, you could use that max function or something like this to actually calculate the max count. That's kind of how we would grade that. So try and like implement everything, even if it's not perfect, right? As long as you can show that you understand, because I think it's easier to understand how to do it in your head than to actually implement it, right? So as long as you can kind of show those steps through your code, that's really what the main purpose of these problems are, right? Are there any questions about it so far? We can just move on to the next question. And this is more similar to what we have on the exams, where you have a long explanation of something where you're going to need to spend the time and actually dissect the problem, right? In this case, it tells us at the beginning, like, oh, we're given these two arguments, and then you have to make this function that does some specific action that we want you to, and then returns. So you're going to need to take all of that information, compile it in like for yourself, and then use that to design your function. You're going to want to do that before you even start writing, as we said. And here we actually gave a lot of those inputs and outputs. But the main thing is look at the examples that we give, because if you can logically understand why we take in our input and you can relate that to the output, and you can change it. If you can see the connection to it, you can really write the code for it too, right? That means that you understand those steps. Even if you can't implement it perfectly in Python, that's fine. We know that you can do those steps, and we want you to show that, right? So don't be too scared of using incorrect syntax. Like for example, I used when I was taking this class, I would use the wrong functions for like sets and whatever because I didn't remember. And that's fine, but it's still understandable. Oh, you're trying to do this. Okay, and that's what we really want to see. Does that make sense? So don't stress too much about like being perfect with your syntax. Something like this that we'll have in the practice exam. This one I wrote based on the I wrote this based on the lab. You might want to practice this one because this one is like a recursive thing. So here you can see I said you cannot use a loop to count the items within this nested dictionary. Now, this means that you could use something else. It doesn't necessarily have to be recursion, I guess, right? But I mean, it does say function should recursively count. So take all of that information so that you can figure out which specific method that you want, because that's what we're looking for. All right. And in this case, well, you're not going to want this. This could be done with loops as you did in the lab, but we want you to use recursion for something like this. So keep that in mind. I don't know. I mean, I would say I don't want to give out the answers because I want you to try it out for yourself on the actual practice exam. Do it yourself during that like time pressure, try and give yourself that environment to practice it. All right. And if you want, because we have the questions here already, you can even make a smaller question that looks similar, try it out yourself, try and code it. And then when you get into the real practice exam, then you can try and code it in the Canvas box so that you feel comfortable when you do it in the actual exam, because it'll be very similar.
Last time I put like a breakdown of how to sort of walk through the free response questions. Would you guys like if I did that again? Preference? I don't know if that was helpful. Was that, yeah, okay, I can do that, yeah.
I don't know if we got anything else. Anything else over here?
About it. That's
Yeah, so that's basically like it for like what we have prepared. I don't want to give out like all the answers for this because I want you to understand that type of process. If you try and do these programs, like these questions yourself, you don't even need to do it in an editor, okay? And the reason why is like when I practice, I would write everything by hand. I would write all my programs by hand because we're trying to get like the logic down, right? We're trying to see your problem solving steps. Okay, so even if your Python is not perfect, you can practice by just writing stuff down by hand or just in a Google document or something that doesn't give you access to write like to run it, because then sometimes you worry too much about, oh, it says that there's an error, but that's not really what we want for this. Maybe in the future it will be more like actually you have to program it and make sure that it's right, but right now that's the main thing that you should focus on and not be scared of, making syntax mistakes, which everyone will, right? Everyone makes mistakes when they're in the exam because we don't have an editor. The editor's nice, but try and focus on that.
Oh, question? Yeah.
Like the response question, like can you put it in my term, or you can just like look at the logic for something? Kind of just like see if it makes sense.
It 99% of the time doesn't run in Python because again, it's hard to write code in a box like that. We understand, and that's why we have a list of items that will say, okay, look for something like this. We'll have multiple different, we'll have a solution, maybe an alternate approach, and say, okay, if they have this type of element, like, oh, they checked C, like in that last question that we looked at, they checked the C and compare those first number and see if the next number is the same, then we give points for that. Right? That's really all we're doing.
I usually do run the submissions through PyCharm just to make sure I'm not missing anything. So if it works in PyCharm, then that's great. If it doesn't work in PyCharm, then I sort of go in and try and break it down. That's usually how I do it. I wanted to, can you log into your Canvas and go to the practice exam?
I can, yes.
Okay, because um a couple of people in my section did this where they like turned their free response question into like HTML and it kind of like messed up their new line. So like it was like fine on their end on honor lock and then they submitted it and then it all ended up on like the same line with like no indentation. So I just want to clarify that.
Okay.
Just go to practice exam too. And just preview and go down to the free response. Okay. Um, so like there's this button right here that's like HTML editor, and then there were a few people that did like their code, right? And then they like switched it to the HTML editor, so it was like this. The problem with this is that once you submit it, it like gets rid of all of your white space and new lines. So then you just end up with all of your code on like one line. So just don't use that. There is a like code format. Yeah, pre-formatted. Or if you go into format, you can see there's a code thing right there. So if you want to use that, you can do that. And I think that might be a little bit helpful, but don't press the HTML button because it'll completely mess up
Oh,
your
yeah.
formatting.
Puts everything right.
Yeah, it puts everything on the same line. So just, don't do that.
The best thing to do is just use the pre-formatted method. I mean, it's not perfect. I don't think you can even use tabs in Canvas, which I think is annoying. I Yeah, it is really annoying, right? And I don't know. Are you guys able to like copy paste like in the yeah. Hmm.